While I was researching the literature about vitamin K2 and its profound effect to stop cancer growth and kill cancer cells without harming healthy cells, I kept wondering, why are we not giving this, together with D3 in appropriate concentrations, of course, to every single cancer patient? And why we're not talking about this in the primary care setting as a preventive strategy for cancer, heart disease, and a host of other chronic illnesses. I mean, this is not brand new research. These mechanisms have been documented in literature for many years. And I think we really need to re-examine our approach to healthcare here. Anyway, I frequently talk about the importance of taking vitamin D3 together with K2 to help the reabsorbed calcium to be directed to bone rather than allowing it to deposit in arteries, contributing to conditions like atherosclerosis and arterial hardening. But vitamin K2 has many other functions as well, including keeping your arteries elastic, increasing bone mineral density, improving dental health, improving insulin sensitivity, preventing dementia, and decreasing skin aging. Now, many people confuse vitamin K2 with vitamin K1, the clotting vitamin, right? Vitamin K1, or phytoquinone, is primarily found in plant foods like leafy greens, and it's an important cofactor for blood clotting, right? Now, vitamin K2, or menaquinone, is found in animal foods and fermented foods like sauerkraut and kimchi, and it's not involved in blood clotting. K2 is also, to some extent, produced by our gut bacteria. Now, when we talk about vitamin K2, there are two main subtypes here, and this is sometimes confusing. There's MK4 and MK7. Now, MK4 is mostly synthetically produced and has a much shorter half-life than vitamin K2 MK7, which is found naturally in fermented foods. And in this video, I refer to the MK7 type of vitamin K2. Now, vitamin K2 is being studied for its profound anti-cancer effects on several cancer cell lines. And there are quite a few case studies highlighting the therapeutic effects of vitamin K2 in cancer patients, and some clinical trials that are apparently ongoing at the moment. Now, in a paper that's published in Oncology Letters, the authors write, a prior study reported that daily administration of vitamin K2 alleviated pancytopenia in an 80-year-old woman with myelodysplastic syndrome and rendered red cell transfusions redundant after 14 months. So that's actually quite successful, right? And similarly, a 72-year-old woman with relapsing acute promyelocytic leukemia, so a type of blood cancer, was reported to attain complete remission following the combination treatment of vitamin K2 and all-trans retinoic acid. Again, fantastic. Now, there are several mechanisms by which vitamin K2 can actually inhibit cancer cells. And again, these mechanisms are known for many years and they have been meticulously documented. They are extremely complicated, and I will simplify them for the purpose of this video and my own understanding, honestly. Now, vitamin K2 can inhibit the proliferation of cancer cells by inducing the cell cycle arrest of cancer cells. And if you remember from high school biology, a cell has to go through several stages in the cell cycle during cell division in order to properly divide into two cells, right? Vitamin K2 blocks cell division in cancer cells. In simple terms, it does this by downregulating the expression of cell receptors and inhibiting the binding of factors to receptors, as well as through other transcription-related mechanisms, right? Now, this causes an arrest of the cell cycle in the G1 and G2M phase. In other words, the cell is not allowed to divide, which is, of course, the hallmark of cancer cells. Healthy cells are not affected by this. Another method in which vitamin K2 actively reduces cancer cells is by the induction of apoptosis. And apoptosis is programmed cell death, which is like a self-destruct mechanism that is often triggered in malfunctioning cells. But generally, this is overridden in cancer cells, and this allows for their proliferation. Again, keep in mind, cancer cells are malfunctioning cells, but this apoptosis mechanism is overridden in them usually, right? Now, in cancer cells, vitamin K2 triggers this process by acting on their mitochondria. So we have to remember that mitochondria in cancer cells differ from mitochondria in healthy cells. And this is actually a very important distinguishing feature here. The mitochondria in cancer cells have lost the ability to produce energy through the citric acid cycle. And this is the elaborate thing that we usually had in high school biology, where essentially we're producing 36 ATP from one molecule of glucose or sugar, right? And they can't do this anymore, so they can only ferment. That's a different, it's a primitive mechanism by which they can only produce 2 ATP per glucose molecule. So it's a very poor energy production. And again, because the mitochondria in cancer cells are defective, they can only ferment. And that's one reason why they need a ton of sugar. That's one of their main substrates usually that they use, right? And the other substrate that they can ferment besides glucose is glutamine, a non-essential amino acid that our own body makes, right? Now, this characteristic that only these two substrates, glucose and glutamine, can be used by cancer cells, and they can only be used in this primitive form of fermentation, is exploited when we add metabolic therapy as a treatment regimen in cancer therapy, right? Now, if you're interested in what metabolic therapy is, then you can click on this video here. Now, in cancer cells, vitamin K2 triggers the depolarization of the mitochondrial membrane and causes the release of cytochrome C into the cytosol, which is the inner part of the cell. And this leads through activation of several enzymes to trigger apoptosis of the cancer cell. So it tells the cancer cell, you got to kill yourself, and it does so. Now, again, this mechanism is unique to cancer cells, and the healthy cells around it are not harmed in this case, right? A third mechanism by which vitamin K2 attacks cancer cells is by evoking autophagy. Autophagy is a process of breaking down and recycling old or unnecessary parts of cells, or sometimes the entire cell, and it can be thought of as a state prior to apoptosis. So vitamin K2 has several mechanisms by which it can actively stop cancer growth. It should also be noted that no adverse reactions to vitamin K2 have been reported in the literature, and doses up to 45,000 micrograms have been safely used in studies for up to 2 years. Now, those are extremely high doses, and they go way beyond what most researchers recommend for daily consumption. Between 300 and 400 micrograms of vitamin K2 daily seems to be sufficient for most people. This is, of course, not medical advice. So why are we not using an adequate combination of vitamin D3 and K2 in every single cancer patient? Now, most physicians are not even aware of the profound effect that these vitamins have in the prevention and treatment of cancer. And I talked in this video here about how important it is to manage your vitamin D levels, for example, because without that, certain cancer therapies like chemotherapy, specifically immunotherapy, does not work very well. So we do need vitamin D3, and it should always be given together with K2, right? And one reason that physicians are not aware of this, again, is that large randomized clinical trials are missing, right? And while we have many profound case studies and very good in vitro studies, as well as a fantastic safety profile, even at very high doses, obviously, of vitamin K2, clinical recommendations are usually not made with this data alone. But the question still is, given this extremely promising information, why are large companies not spending millions of dollars on studies of this naturally occurring, non-patentable vitamin that seems to be a logical, cheap, invaluable part of any cancer treatment regimen? Well, I really can't figure it out. Maybe you have some idea. Now, I talked in this video again about the importance of vitamin D3 in cancer patients, and in combination with adequate doses of vitamin K2, this should be part of every treatment regimen in that patient population, in my opinion. And what about the healthy population? Now, again, I cannot make recommendations here because dosing may vary from person to person, because there might be underlying conditions where lower doses are recommended. But personally, I am currently taking between 5,000 and 10,000 international units of vitamin D3 with 400 micrograms of vitamin K2. I do check my blood levels of vitamin D3 and calcium every 6 months. So again, the frustrating part here is that very safe doses of vitamin D3 and K2 that have huge benefits beyond in the application in cancer patients, but also for the general population, again, to mitigate or prevent many diseases, that they're not recommended by physicians routinely, and that we don't check for them either, right? And there's a host of illnesses that may result in low levels, especially vitamin D3, that can be remedied by this simple, cheap intervention. And it's a bit of a shame that we as physicians are only really interested in pharmacologic compounds. And a part of that is, I think, our training, that we're heavily influenced by the pharmaceutical industry, because it works hand in hand with the medical institutions, to prime us to reject anything that is not, again, a pharmaceutical compound, something that's naturally occurring, and we just write it off as some homeopathic stuff that we don't understand and we feel has no effect, right? The money, of course, comes in when you have a medication that you can patent and sell, But I think, again, as physicians, we should look beyond that and say, listen, if we can improve the health in our patient population significantly with simple strategies like this, then we should really try harder to understand this and make recommendations, at least do blood tests and see if there are certain presentations of symptoms, if they can be improved by optimizing these vitamins and minerals. If you found this topic interesting, then you should check out this video here that talks about how to keep your mitochondria healthy, and this video here that talks about the impact of methylene blue on our cells, mitochondria, and overall health.